Sometimes small differences in the definition of a problem can lead to large differences in the code you write, which is a little weird if you think about it. To the extent that two problems are very similar, you'd expect their solutions to be similar too. To lay the groundwork for some later discussions, let's look at 4 ways you might approach a programming task where small changes in the problem definition will eventually lead you to solve that task quite differently. I'll use JavaScript and Node for this because I'm comfortable with those, but the problems I'm talking about aren't really specific to either of those things. Suppose that we have a set of people. Here we've got 3, and for each person, we're going to associate that person with some data. Let's say a greeting that includes that person's name. So each person's data is different and depends on who they are. And given this situation, our task is to display the data for all the people. We want to display all of these messages. So depending on our precise requirements, we might approach this problem in different ways. Let's start with a really simple approach. If we've really got something, a set of data that's this trivial, we can use a JavaScript object to hold all the data. So here we've got keys, which are the person's names, and then we've got the data as the values in that object. So we can just use the JavaScript language features to iterate over the keys in this object. For each key, we can get the value that goes with that. So for Alice, we'll get hello Alice, and then we can log all of that. If we open up the debug console and then run this, we see the expected output. Hello Alice, hello Bob, hello Carol. Okay, so that's a super simple, straightforward example. Now let's change the problem just a little bit and see how differently our code ends up being. Suppose that we know that the message or data that we're going to want to associate with each person is more extensive, not just a little snippet here, but a lot of content. And or we've got lots of users. And so maybe doing this all in a single JavaScript file is going to get unwieldy. So one solution we might reach for is to store the data for each person as a file in the file system. So we've got a folder here called people that contains files. Each file is identified with the person's name, and then each file contains the data that we want to associate with that person. With that, let's say that we're going to have our approach. We're going to do the same thing we did in our object example, except we're going to read the data out of the files. So we can use the Node API to do that. We're going to need to get a reference up here to first the folder that contains this particular source code module. Then we're going to have to go up and over to get to the people folder. And then we'll start making some more file system calls. We want to get the set of files that's in that folder as an array, and then we're going to read all of those files into memory. Now, because file system APIs are often asynchronous, like in this case, we're using the promises version of the file system API, we'll use the JavaScript await keyword to read the set of files, and then also to read the contents of a specific file. We'll read those as buffers, and to take advantage of the asynchronicity, we'll kick off all the async requests at once and wait for all of them to finish. So instead of using a for loop, maybe it's convenient to use a map function and then wait for all of that data to come back, and then we can display it. So if we run this, we see the same result that we got before, but the code's pretty different. I mean, we've all we wanted to do is store this data in the file system, and we're led to use new programming concepts like async functions. We've got this totally new API and new language features to work with all this. One reason that these approaches, the object one in-memory object and the file system approaches are different, has to do with latency, which is to say the time delay necessary to read or write data. Latency turns out to be a big driver of implementation differences. So let's talk about latency for a minute. Here we've got a high-level conceptual diagram showing some parts of the ecosystem you might find yourself coding in if you're creating, say, a website. You're over here on the left working on your machine to build an app like a website, which is going to run over here on this machine in the middle, this web server, that your user is going to access with their client machine over here on the right. If your code is running on one of these machines, say your dev machine, then it can access information in memory on that same machine very, very quickly, essentially instantly. There's almost no latency. If your code needs to read or write files on that same machine, so local files, that operation is still pretty fast, but it's going to be slower than reading or writing memory. So for that reason, file system APIs are often asynchronous, which is to say that when you ask the file system to read a file, it'll say, okay, I'll get back to you when I've got the data you wanted, and in the meantime, your main thread can go do other work. So latency is one of the reasons that we end up with a difference between this very simple object-based approach with this more involved file system-based approach. Okay, let's look at a third approach to solving this problem. Let's imagine that we're looking at this particular pattern, and maybe our problem constraints are such that instead of just having a convention that the greetings all look like this, let's say that pattern is going to be strictly enforced. It's always going to look like this. It's just a template with the person's name stuck into it. So in that case, we could generate the data for a given person on demand instead of storing it. So our third approach will be to implement that with a function. So we'll just have a function that, given an argument, will return hello, and then that argument. That's our function. We'll define a domain that function is going to operate over. So in this case, the set of names. And then for each data item in that domain, we'll invoke our function, get back a result, and log that. If we run that, we get the same result. But again, this is slightly different in how we work with it. So for one thing, we've got the function and the domain now are separate objects that we have to manage. There's no single standard object in JavaScript for that. So we have to invent a convention for it. And this particular function is synchronous. So it's a little bit like the code here ends up looking a little bit like the code that we used for our object example. If this function were async, maybe it's going to do a lot of work, then we might make this function asynchronous, and the approach would be a little more like our file system-based approach. So for our fourth approach, let's imagine that this function needs to do so much work or has other constraints on it that we'll want to run the function on a different machine. So we're going to run that, say, in the cloud and get the data back. So maybe the place where we want to display the results is on this web client, but the function is going to run on this web server, or maybe we've got a service for that. The basic point is that we're going to run the code somewhere else. And in that case, we've got to read and write data over the network. And as our diagram suggests, that operation is going to be much, much slower than accessing data in local files or accessing information in memory. And then for various historical reasons, the API we'll use to access a server is going to end up being different than any of the code that we've written so far. So first, we're going to need to start out, there's this other historical thing. A web service doesn't have any standard way like a file system does for indicating what data it's got in it. So here, a file system folder can return through a standard API the files that are in it. There's nothing like that for a web server. So what we're going to do is we're going to have a little service running in the cloud. And what we'll do with that is that we'll create a convention where we'll have a particular endpoint that's going to return an array, kind of like in our function approach. And then for if we hit that same service and we pass in a username, then we're going to get back the data, the function generating that data on demand and sending it back to us. So here we're going to end up using a different API, the fetch API. We'll get that as a buffer that we're going to need to convert into JSON, use the JSON parsing to convert that into an array. Then we're going to want to map each of the routes there to their response and then display all that data. So if we run that, we get the same result. So we get the same output in all four of these cases, this object one, this file system one, this function-based one, or this website-based one. But given slight changes in the specific constraints of the problem, the code ends up being pretty different. Some of those differences are due to technological constraints like network latency. Some of them are due to historical differences in API design, like the differences between the file system API and the fetch API. And at this scale, the differences are small, but those differences will get amplified as we try and tackle more and more meaningful problems.